Alright, we are on 8.3. We're gonna start on page 142. And this section is volume and surface area. SA stands for surface area of cones. So page 142 is talking about not only cones, also pyramids. So on page 142 you can see they've got the base and the height of different pyramids. Some of them have a square base, that makes them a square pyramid. Some have a triangular base, that makes them a, yes? No, it's got a triangular base, it's a triangular pyramid. There you go. Cones, so it talks about volume of a pyramid. When we talked about the volume of things before, we said big BH, right? Area of the base and the height. This one is a little bit different. It is 1/3 big B and H. And that's going to change because some of them have triangular bottoms, some of them have square bottoms. So it depends on which one it is. Just make sure that you're recognizing, hey, this is area of the base. Whatever base that might be. Obviously a square is a lot easier to find the area of the base of a square. Sorry, it's a lot easier to find that area of a square than it is an area of a triangle. Do you have something to work on? The other thing is volume of a cone. And that again is 1/3 big B H. So both times you have area of the base in them. So essentially a cone and a pyramid are the same thing, right? No, what's the difference? A cone has a base of a circle. Yeah, a cone has a base of a circle. But other than that, they're not really going to have any difference. The one thing that you do need to make sure you're watching out for here is if this is a cone, when we think, hey, base, we know, hey, well, the area of the base must be, area of a circle is what? Pi
times radius.
Nope, pi radius squared, yep. Pi times radius squared. So if you want to rewrite the formula for a cone, you can say 1/3 pi radius squared times height. That's the one I would write in my notes for the volume of a cone. 1/3 pi times radius squared times height. The one thing you do need to make sure, this is the actual distance from the center of the circle to the top. That is the height. This right here, from the outside here, that is called the slant height. So there's a difference. Slant height is going to come in handy, but it's not going to come in handy for volume. It's going to come in handy for, what's the other thing we're figuring out this chapter? Not volume, but surface area. So surface area, keep slant height in mind, but you're not going to use it now. You're only going to use it when we get to surface area. For the volume of a pyramid, 1/3 big BH, I'm not going to write in I'm not going to write in a more specific thing here, because it's going to depend on whether it's a square base, or a square base, or if it is a triangular base. But either way, you got to keep in mind, hey, this big B, that's the area, whatever the base is. If the area of a triangle, length times, or base times height divided by 2. If it's an area of a square, just length times height, or base times height, I should say. And then you're still figuring out whatever the height is, that's got to be the, let's say it's a square pyramid. It's still got to be the direct height up from right here. It also has a slant height. This part right here is a slant height, but again, that slant height's not going to come in any use for when you're doing volume. It's only going to be useful for surface area. Yeah. anyone need any more of this part for writing things down in their notes? Because this is, these formulas in particular, this one right here for volume of a cone, and making sure that you have volume of a pyramid and acknowledging or having it written down in there in your notes that you can have a square pyramid or a triangular pyramid. Okay. Next page, or no, bottom of that page. So it says find the volume of a pyramid. You've got that pyramid has a square base, so it's a square pyramid. Remember, what were our steps that we had from before? And then written in our notes. At least that's what you're what I told you to do, write them in your notes. And we got them, I believe there's 3 steps. Yeah? Write down what you know. So what do we know on page 142? What does it tell us on the bottom of page 142? Okay. Height is 8 centimeters. What else does it tell us?
One side of the base is 6 centimeters and the other is 4.5.
Okay, so I'm going to say length and width. Is this going to be different than if it's a square pyramid? Because this obviously is not a square pyramid for the base. We're thinking like, hey, this is what this one looks like. This is more of a rectangular pyramid than it is a square pyramid because one of them is going to look a little bit different than the other. The height is still the height straight up, as far as we can tell. Yep, height straight up. And then length is 6 centimeters and width is 4.5 centimeters. So 1 was write what you know, 2 was what? Right, what's the formula for the volume, because we're trying to figure out volume of a pyramid. 1/3 big B H. Now we know, and then after we write the formula, we need to. Yeah. Do we know what the volume is already? No. There are some parts that they're gonna tell you what the volume is, but we don't know what the volume is right now, and that they're gonna start off with that, not telling us what the volume is. 1/3. We know that the height is what, 8?
Yeah.
But the base is. How do you figure out the area of the base here?
6 times 4.5.
Yeah, 6 times 4.5. 6 times 4.5, and I'll put that back there. And now, I gotta see if I can make some magic with things. So, yeah, you can use the, you can use your calculator on this, but I would say, what can you figure out first? So I want you to first figure out what can you figure out by yourself without using the calculator here. Remember, multiplication, we can move it around, that's called what property? The, nope, what? Commutative property means we can move things around. So, what do you notice, what are some things we can move around right away? We've also got something that's a fraction here. Does that fraction combine with any of these numbers really nicely that we can get rid of the bottom of the fraction? Yep, the 6. So we can put this 6 over 1, and now 1/3 times 6 becomes, both divided by 3, this becomes 1, this becomes 2. That just becomes 2. So now we've got 2 times 4.5 times 8. Is there anything that goes really nicely there together? What?
8 and 2.
There's something else that goes even nicer. Because if we do 8 and 2, then we're going to have to do 16 times 4.5. Do you know 16 times 4.5 off the top of your head?
Yeah.
I don't either.
No, actually, I do.
What?
3 times 4.5.
Yeah, 2 times 4.5, which is
9.
9. 9 times 8 is... What?
72
Yeah, 72. And what's the
centimeters.
centimeters what?
Mm.
Yeah, centimeters cubed. So this is not one that you should need to use a calculator on. Yes, you have to use a little bit more of your brain on it, but unless there is something that you can actually say, hey, I need to use a calculator on it because it's doing this other stuff, I'm going to require you go through and first look, hey, can I use the commutative property here to do these things? Because that's a big, easy, nice way of building your math skill. What's up? What? Oh, yeah, go ahead. So 72 centimeters cubed for that one. Then let's do let's just do number one. We'll skip number two. So guided practice number one, you can start it by yourself already, but it's got a, first thing, write down what you know. It says the triangle base has the triangle base of 5 centimeters and a height of 3 centimeters, so, I think, so, I'm gonna say height of 5 centimeters? Base of 5 centimeters, height of 3 centimeters, so, this is 5 centimeters, and this is 3 centimeters, and then the pyramid has a height of 6 centimeters. So, that right there is 6 centimeters. So you write out what you, step one, write out what you know in the formula. 2, write the formula out. 3, replace what you know. So you should be doing this by yourself on paper. Alright, so I wrote out what I knew. Base is 5 centimeters. The height of the base, is where the base of the triangle is, that is 3. And the height of the pyramid, I specified pyramid, is 6 centimeters. Then wrote out volume is 1/3 big BH. Gotta figure out what big B is first, so I wrote out the formula for the area of a triangle. Area of a triangle is 1/2 base times height, or sorry, that should be a little b. 1/2 base times height. Well, I know the base of this triangle is 5. The height is 3. So 1/2 times 5 times 3. 5 times 3 is 15. 15 divided by 2 is 7.5. So again, don't need any calculator for this. 7.5 goes where big B is, because that's what the area of it is. Make sure, the big thing is, make sure you don't forget this right here. If it's got the base is a triangle, that's the part that you can't forget. So 7.5 times the area, the height of the pyramid was 6. 6 times 7.5 times 3, well, I know that I can make all these into fractions, so I did 6 and 3. If I put this as 6 over 1, divided both of them by 3, this becomes 1, that becomes 2. Now I have 2 times 7.5, so my answer is 15 for the whole thing. Comments, questions? Want me to do another one? Or give you guys another one so you can practice it more? Okay, well you can go practice the other one more on your own time if you'd like, otherwise you can watch this video back. Bottom of page 7, this is the last thing for today. Find the height of a pyramid given its volume and area of base. So basically, no pun intended, as I said basically. Basically what they're doing here is find the height of the pyramid. You're gonna do all the same things, You write down what you know first, but now one of the things they're gonna tell you is the volume, and you just have to work backwards. So it says a rectangular pyramid jumbo has a volume of 260, volume is 260 inches cubed. The base, and it's a rectangular base, base has a length of 15, width of 8. Length of 15, width of 8 inches, and they're asking us what is the height. So I'm going to start off same thing. I write down what I know, then I write the formula. Volume equals 1/3 big B H. What do I know? Do I know what the volume is? Yes, I do. Volume is 260. 1/3, I keep as it is. Big B, well I know big B is the base of it, which is going to be 15 times 8. So I don't even need to do 15 times 8. I can just write in 15 times 8. And what's the height? I don't know what the height is. That's what I have to figure out. Anything I can simplify here? Because eventually I'm going to get the variable by itself, but I don't have to do that yet. Anything I can simplify. 1/3, 15, 8. I'll multiply. What? Yep, 15 and the 1/3. This becomes 115 becomes? Yep, 5. Now, all I have is 1/1 times 5 times 8. What's 5 times 8? 40. So I have 40H equals 260. Notice, did I have to use calculator at all here so far? No. All of this is mental math you should be able to do. 40, how do you get 40H by itself? How do you get H by itself? Actually divide by 40, because you want to undo what's already being done on that side. And now I have this, 26/4, that can be reduced. I can divide by 2, becomes 13 divided by 2. What's 13 divided by 2?
6.5.
Yeah, 6.5 or 6.5. 6.5 inches is the height. Did I have to use a calculator anytime there? No, and they're intentionally writing it that way so that, because they're not trying to say, hey, can you do these huge multiplication things? They're testing, one, do you know how to find the formula of stuff? And two, can you manipulate the formula? Can you use like the commutative property? Can you cancel out things right here so that you don't have to do all that other stuff? If there's one where you think like, hey, I need to use a calculator for it, just talk to me about it, and I'll be like, oh, yep, that makes sense. But most of them, I don't think there should be any on your assignment that are like that. Let's do number 3. Guided practice. When you're done with that 3 guided practice, you can check in the back and you can start on your assignment after that.